Yeah, welcome to this discussion on the project related to Coursera managing machine learning projects. So the idea was basically we have to present a use case and just kind of go through the complete life cycle of how you will build the use case and what will be the technical challenges. So to introduce the topic, I would say what I'm picking is basically in the mechanical system. It is important to know, right, whether there is any need for maintenance, and it will be good to know, beforehand, under what condition my machine will fail. So that will improve the downtime of the machine, and basically it will also improve overall impact of the failure on the plant or the company on which machine is running. So why build a machine learning based use case, right? So is there a problem? Yes, there is a problem, right? Because an automated solution which can help identify the failure of machine will be good indicator, right? If the machine needs maintenance or not. Does someone care? Yes. The stakeholders, all the stakeholders which are involved, right? Starting from the one who is operating the machine to the one who is sitting at the top of the hierarchy will benefit from it. Because for both of them, it will be an improvement on the productivity and the monetary benefits as well, right? Now, can ML help solve it? Yes, it can help solve it because data is will be available, right? Data can be collected, and then on top of that, we can build a machine learning based automated solution that can help solve this problem. Now, crisp team process on how business understanding on how the problem. So defining the problem. So target user will be kind of a factory supervisor, right, who is kind of managing multiple machines. Right? That could be our target user. Then problem statement again, provided the machine running in a specific condition, predict if it is going to fail in or not. Now it will benefit all the key stakeholders across the companies. Now current state again, it will be depending on the regular inspection of the machines. That could be one way to identify this. Or in worst case, you will be able to know that machine needs some kind of action after the failure. Now the gap is basically there is a loss of productivity and time. Right, downtime of machine is going to cost a lot to the company. Or success criteria or the defined success would be like data prospect of failure beforehand. Factors identified will not change drastically during quick span. That is the assumption that I'm making. Output matrix will be like how accurately system is by identifying the case when machine is about to fail. And outcome matrix could be improved downtime of the machine. Right? Identify key factors, so atmospheric pressure, temperature, right? So basically, machine is running in a atmospheric, ecosystem, right? So these are basically are my main identifying factors, right, that are going to impact how machine is running. Apart from there will be a few more, which I'll be discussing in subsequent slide. Now load on the machine. So again, that would be another factor. Maybe if there is any drastic change on the load of the machine, that is also going to impact the machine tier basically, and then eventually your maintenance might be frequent or infrequent based on the load. Now solution validation plans. Solution what I'm proposing is basically preparation of model ready data with features like air temperature, machine temperature, RPM on which machine is running, torque which machine is facing, tool wear if there is any wear on the tool. Now target will be a boolean flag indicating whether the machine is failed or not. Now it clearly looks like it's a classification problem, right? So we are going to predict whether it is going to fail or not. We can extend it also maybe based on failure type also in the version 2.0, I would say, right? Like what is the kind of failure, right? But for now we are just focusing on whether it will fail or not. The key metrics here should be precision because we want to know when it will fail, right? We don't want to know whether it will not fail. I mean, that is okay, but more important for us is when it will actually fail, right? So that is why key metrics I am considering here precision. And evaluation metrics, again the performance on the test data would be a good indicator. Again, we also might want to know what are my key factors which are impacting my failure, right? For example, out of these features that we have selected, air temperature, machine temperature, RPM, tool wear and torque, what is the which feature is causing major impact on the failure, so we can optimize it to improve the machine life. Now trying out different hyperparameter combination and evaluate the performance, right? So cross validation, all those techniques can be made here. Now I'm a system design, so based on the three components that we have gone through in the module, So whether it will be cloud versus edge, so we'll be going ahead with cloud because there is no privacy concerns. There's no data which is having some kind of PII data, so that's okay. And also, internet connectivity is something that is something which we anticipate. Now, offline versus online learning. So again, retrain. So idea here is we should do offline because we are not going to retrain on every data that is coming in for inference, right? We are only going to do maybe on a monthly basis or on a weekly basis. So there will be a fixed schedule, monthly, weekly, or something of that sort, right? And it will be easier to move to production as well. Productionization will be easy in this case, and your whole ecosystem would be very, not will be very complex, I would say. Now, batch versus online predictions, again, we don't want to, so we have to be very careful if we make it as a real time, prediction. Now, what can happen is there could be some anomalies also. There could be one case where some cases where it is a false positive, right? So we need a way with which we can do it periodic, right? So maybe we can have scheduled runs on and do infer on the model. Maybe on hourly basis we want to monitor, or maybe a 6 hours basis based on what is my load, what is my domain, based on discussion with the domain expertise or the company supervisor, I would say, right? We can decide that what will be the batch, but yeah, should be a batch because we don't want to go for a real time, because the failure will happen gradually. It will not be that okay, your machine will fail at exactly that one particular point in time, the moment the first year happened or first time temperature goes out of hand. Now it will help also in monitoring the data to detect drifts, right? So it will help in monitoring the drift as well. So that will be what I would say the system design, cloud, offline, and batch. Now, potential risk in productions. So basically, again, feature drift could be a very important aspect to monitor because outside temperature might change, maybe it may change with the season or during a specific duration of the year, or due to certain change in demand of the product, machine runs in heavy load. Or when there is very drastic reduction in the demand, the machine runs with a very less load, right? So there is a drift on how my features will change. So feature drift will be a good thing to monitor continuously. Also, we also want to monitor the concept drift to make sure that the relationship that we have maintained, we have formalized between the feature and target does not change over a specific threshold over time. So that again will be a good thing to keep in mind. Performance drift also should be monitored across runs. Because we want to also make sure the performance, which is in this case I would say the precision, right? We want to accurately predict if that machine is going to fail, right? That is our main interest, right? So that also doesn't change over time, with new arrival of the data. Yeah, so this concludes our use case. So basically, to summarize, the use case was basically given our environment conditions, we have to predict whether the machine is going to fail or not. Now, when I say environment conditions, these are basically air temperature. There are certain machine properties as well, like the machine temperature, torque, tool wear, RPM. Okay, and the key evaluation metrics will be precision. We want to accurately predict when there will be a failure. That is of major interest. We want to use offline learning, batch mode for inference, and cloud-based system for this, right? And for monitoring, we want to monitor on the feature drift, the target drift, and the concept drift. So that concludes the presentation. Thank you.